to do was basically start at question 1. So we've got 2 sessions on paper 1. So what I wanted to do was start at question 1 and maybe get up to somewhere around about question 6 today, and then I'll do from question 7 to question 11 in the next session. All right. But if there's anything from this week that you still didn't understand next week, after you've had a chance to have a look at the memo, then you can always bring up those questions again. You are going to have a chance to answer all of these. Some things we can't answer, or we can't say whether it's an easy question or a difficult question until we've actually had an opportunity to try anything. But what I'm going to do is I'm going to start at question 1.1.1, and I'm going to ask you, oh, you usually receive the memo afterwards. Thanks, Gugu. Is ask you where you felt you didn't understand. So if it's things like question 1.1.1, we should all be able to do that. Question 1.1.2, we should theoretically all be able to do that. Question 1.1.3, 1.1.4, those would be questions that might cause a little bit more problems. So just please, I need you to interact with Neliswa and I. Please stop me, but I'm going to go through them and then you tell me where you think. Okay, so Gugu, you got stuck at 1.1.2. Now, it's interesting that you say that, Gugu, because it's a little bit different to what you would normally get, which is really nice opportunity for you to and then 1.4. Yes, absolutely. Okay, so tell me all the issues in question 1, and then I'm going to highlight them, and then those are the ones that I'm going to do with you. And then if there's anything else that you struggled with next week, we can pick that up. Okay, so we're going to do 1.1.2. We're going to do 1.4. That's fine. Layer 2, 1.3. Says Kutwano, that's fine. That's always a problem on roots. 1.4 said Mary Lynn. Msomi, you said the same thing. 1.4. Let's see if anybody else. 1.3. Okay, Mbali, that's fine. I've got that. So I'm working on the understanding that we're going to do 1.1.2, 1.3, and 1.4 from question number 1. If anybody else thinks of anything, then let me know before we move on, and you'll get the memo later. Okay, so in question 1.1.2, this is a throwback from something I anticipate the first time you would have seen it would have been in grade 10. Yes, in grade 10. And what they want you to do with this particular question is you need to deal with the fact that you've got a denominator. So when we've got a denominator in an equation, we've got a fraction in an equation, what is the process for dealing with that denominator? How do we get rid of the denominator? Can anybody tell me? What's the method that we use?
Would we not multiply the whole sum by x?
Yeah, exactly. Absolutely. Well done. Well done. That's perfect. And you're all saying the same thing. Multiply each term by the denominator. Beautifully put, Lilu. Thank you. All right, 100%. So we're going to multiply every term by x. This would give us 4x squared plus, then I'm going to bring the 11x into the middle, and I'm going to put the plus 4 at the end like that. And then I just get it into standard form straight away. Okay, everything has to be multiplied by 4. So when you multiply 4 over x with x, you're going to end up with just 4. All right, and then because the question says correct to 2 decimal places, that is an instruction for us that we have to use the quadratic formula. Okay, so in your question papers, you will also, in your second question, that will be where you use the quadratic formula. This will be the question where they penalize you on rounding. Okay, they will not penalize you on rounding anywhere else in paper 1 or in paper. They could penalize in trials. Sometimes they penalize in paper 2 in statistics, but in finals they will only penalize you in paper 1 in this second question. So make sure that you round 100% accurately so that you don't lose any marks. Okay, so now it's a case of subbing it into the quadratic formula. Remember in class, I've reminded you guys, the rule is when you use the quadratic formula, you've got to show that you're subbing into it. Okay, you cannot just get to standard form, write the formula on the page, and then do it on the calculator. You must show that you have subbed in. Okay, make sure that you use your bracket for b squared, especially if it's negative. Okay, oopsie, sorry. I'm not writing the 4 here, which is silly of me. No, Mary Lynn, you don't have to do that. You can sub straight into the formula and save yourself a little bit of time, but you must show that you've subbed into the formula minus 4ac. Okay, because you get a mark for this. All right. So this question is out of a little more. It's out of 4, and that's because let's just do this. It's because there was this manipulation that we had to do first to get it into standard form. Okay, but you must show the substitution. Okay, so anywhere in your paper, if you use the quadratic formula, make sure you show that you have subbed in. Okay, doesn't matter whether it's question 1 or question 5 or question 7, not that you'd be using the quadratic formula for financial maths, but you must show that you have subbed in. Okay, and then when we do that, we're going to arrive with 2 solutions to x. I am getting, sure you guys are getting answers as well. Okay, so the first answer I'm getting is negative 0.43. Or the second answer, if I remember correctly, was also negative. Yes, negative 2, comma, and now this is where we need to be careful. It's negative 2, comma, 318. So I've got to round this to negative 2, comma, 3, 2. Okay. That's it, Cheslin, quite right. Okay, so you see where you went wrong. Shamson Elise was just asking you where that was. Okay, cool. All right, well, I'm glad that we've managed. Yes, that's perfect, Cheslin, quite right. Okay, so you'll be able to see on your memo where the marks were allocated, but it would have been a mark for multiplying through x and getting it into standard form, always a mark on substituting, and then a mark on both of our answers like so. Okay, all right, let's move on. I'm going to go and do question 1.3 next as per our agreement at the start. And they've said to us the roots of a quadratic equation are given by x equals minus 2 plus or minus root 4 minus 20k. Determine the values of k for which the equation will have real roots. So the key here is that they are speaking about real roots. Do you remember this here they're talking about delta. They're talking about b squared minus 4ac, the discriminant. What is the value of the discriminant when roots are real? There's a restriction, one could say, on delta for real roots. Can anybody remember what that is? There's a restriction on delta. Let's just see what you guys are saying. That's it, Letu. Well done. Bigger or equal to 0. Good, Letu. That's beautiful. Okay, so delta has to be 0 or it has to be positive for roots to be real. Okay, so remember, real roots means your parabola has an x-intercept or 2 x-intercepts. Okay, so in other words, the parabola is touching the x-axis. Either the x-axis is a tangent to the parabola, in which case we've got equal roots, or the parabola goes through the x-axis and there are two x-intercepts. That's what they mean for real roots. So we are going to have a look at the value of delta in this case. Now, all of you can see that delta has a value of 4 minus 20k. That is b squared minus 4ac. Not that you would write this, but b squared, I'm just going to put it over here. So b squared minus 4ac is equal to 4 minus 20k. Okay, those two things are the same thing. All right, so what we're going to do is we are going to take our b squared minus 4ac, which is 4 minus 20k, and we're going to solve for k when b squared minus 4ac is greater than or equal to 0. Okay, so that's what they are looking for. That would be your first line. Okay, or you could write for real roots, delta is greater than or equal to 0. Okay, and now you need to solve this linear inequality. All right, so I'm going to leave, always when you solve a linear inequality, leave the term that you are solving for on the left, move the other term over to the right-hand side. And now we need to solve for k. So we're going to divide both sides by negative 20. What happens when we divide an inequality, a linear inequality, by a negative? The sign swaps round. Exactly. The sign changes. Okay. So k is no longer going to be greater than or equal to. It's going to be smaller than or equal to 4 over 20. Okay, which would be 1 over 5, like so. Okay, is everybody happy with that? So a mark here on your first line and a mark on your answer. All right, so those people that were struggling with 1.3 in the beginning, does that make a little bit more sense now? Are you all good? All right, Tariro, thank you. Perfect. Okie doke. So if everything is okay, then I'm going to move on to question 1.4, which is a lovely, lovely, lovely question. Kutwana, don't do that. It is okay, but when you are solving an inequality, you want to read from left to right. So you're not solving for the number, you're solving for the letter. So rather leave the letter on the left and put the number on the right. That is convention. That's the better way to set it out. Okay, so I would rather leave your x term or your k term on the left-hand side and take the number over to the other side so that your variable is on the left of the inequality sign rather than on the right. Okay. All right. So the other thing before I get started on question 1.4 is I just want to again emphasize to you guys, make sure that when you are answering your questions, that you number your questions 100%. So this is something that I've been saying to you a lot in class. They are not going to assume anything on your part. So make sure that you've numbered the questions correctly. They're not going to write in the numbers for you and you're going to end up losing marks. All right, so just be pedantic about that and getting your numbering correct. Okay, so question 1.4, the sum of the digits. Okay, so this is a question based on exponents. And what this question expects you, that the crux of the matter of the question is this concept over here. When I have two different bases, so let's say I have 3 to the power of 4, and I multiply that by a different base but with the same exponent, there is a particular exponent definition or rule that I'm allowed to use in this case. Can anybody tell me what that is? What's the rule or the definition when I multiply two different bases but the exponents are the same? Indeed, Letu. So under these circumstances, you are allowed to multiply your bases together and keep your exponent. So in other words, 3 times 2 is 6. This will be equal to 6 to the power of 4. And you keep the exponent the same. Absolutely. Yes, well done, Letu. You are indeed a superstar. Okay, so that is what this question expects you to know and understand. So just quickly do that on your calculators. 3 to the power of 4 is whatever. What are you getting for 3 to the power of 4? You should be getting 81. Cool. And 2 to the power of 4 is? Two to the power of 4 is? Cool, it's 16. So now multiply 81 and 16 together. What do you get? Cool. Okay, so now I don't know if your calculator will, you can't ask it to do it with a base 6. I was going to say, if you go shift fact, it'll just go back to what we originally. Okay, all right, I know how to do this. Okay, so now you know that it's 1296, right? So now calculate what 6 to the power of 4 is. Can you see you getting the same answer? It's 1296. Do you see that? Okay, so that's where the rule comes from. Okay, but it only works if your exponents are the same. So you can multiply different bases together if the exponents are the same. So let's say I have 2 to the power of 7 multiplied by 5 to the power of 7. What would that leave me with? So as an exponent, this would be equal to 10 to the power of 7. Does that make sense to everybody? Yes. Okay. All right. Cool. So that is what this question, lovely. So that's what this question wants you to do. When they ask you to determine the sum of the digits, they want you to create a base 10. So you create a base 10 by multiplying 5 to the power of an exponent by 2 to the power of the same exponent. So can you see here, you've got 2 to the power of 2010. So what you can do is you can keep the 5 to the power of 2009, and you can multiply that by 2 to the power of 2009 as well. So your bases are different. Your exponents are the same, and you are going to create a base 10. That means that there is an extra 2 to the power of 1 floating around. Remember, when you multiply like bases, you add your exponents, and then that can be multiplied by 24. Oh, okay. So, Gugu, what I was trying to say with this particular question was, if you multiply 2 different bases together, but their exponents are the same, you're allowed to multiply the bases. So for example, if you've got 3 to the power of 4 and you multiply that by 2 to the power of 4, you will get 6 to the power of 4. That's what this question works off, is understanding that. Yeah, maybe Neliswa, if you just want to reach out to her and just help her to catch up to the rest of us. Thank you so much. All right, so now you've got 10, so you can multiply the 5 and the 2 together to the power of 2009. And here, when you say 2 times 24, that will give you 48. Now, in reality, not that you would have to do this, but maybe I should just not do it there if it's not something that we need to show. So now if we take 48 and we multiply it by 10 to the power of 2009, it's going to be 48 with a whole bunch of zeros afterwards, isn't it? And these zeros are going to carry on going. up to a certain point. All right. So when they say to you the sum of the digits, it's not going to change your answer when you add all these zeros together, because 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 is still going to be 0. So therefore, the only digits, they are not significant digits. Okay, if you add 0, it's not going to change your answer at all. So the only significant digits you've got are the 4 and the 8. So when they want the sum of the digits, they now want you to add the 4 and the 8 and all those zeros that are not going to change your answer. So the sum of the digits would be 12. Okay. And that was what this question was looking for. So yeah, a mark for splitting this off, like maybe not there. 1, 2, mind you. Yeah, having that, or maybe on the adding. I can't remember exactly where the mark went, but you could look on the memo. Okay. Does that make more sense to everybody who was struggling with 1.4? Okay, but think about it, iPhone. I'm sorry I'm calling you iPhone. Okay. What if you multiply any number by 10 to the power of something? What happens to that number? Okay, so let's say I take the number 13 and I multiply it by 10 to the power of 2. What do I get? What happens when I multiply 13 by 10 to the power of 2? Exactly, I get 1,300. Okay, so what happens if I take 13 and I multiply it by 10 to the power of 5? What do I get then? Exactly. All right, so I get a 13 with 1, 2, 3, 4, 5 zeros afterwards. Okay, so now what happens if I take 13 and I multiply it? So when I took 13 and I multiplied it by 10 to the 2, there ended up being 2 zeros after the 13. When I multiplied 13 by 10 to the power of 5, there ended up being 5 zeros after the 13. So now what happens if I take 13 and I multiply it by 10 to the power of 2009? What am I expecting to get? Exactly. And what happens when you add zeros together? Exactly. So the sum of the digits, exactly, it stays 0. So the digits are, so in this question over here, your digits are 1, 3, 0, and 0. So if I say to you, what is the sum of the digits? The sum of the digits is 1 plus 3 plus 0 plus 0. But me adding those zeros on the end didn't make any difference. So the only sum of the digits that I need to worry about are the significant ones, which are the 1 and the 3. So the sum of the digits would be 4. Does that make sense to everybody? So it's exactly the same thing with this question over here. You have got a 48, right, with all of these zeros behind it. Is it making a bit more sense to you now? So you've got 48 with 2009 zeros afterwards. So it does not matter how many times you add all those zeros together, you're still going to get 0. So the only digits that are going to create something other than 0 will be the 4 and the 8. Okay. All right. Hopefully that makes a little bit more sense now. Are you feeling a bit more confident about this question? Oh, it's a pleasure. It's a pleasure. Okay, so sometimes we just need somebody to just go through something again with us in a way that we do understand it. So hopefully what I did down there in in the pink, we're using 13 times 10 to the power of whatever, helped you to understand this question a bit more. Okay, now again, don't be put off by a question like this. This is 4 marks. You've still got another 21 marks. So make sure you do the questions that you know how to do first. I know all your teachers are telling you that, but it really is very important. If you see a question like this, and there will be a question in question number 1 that will be a more difficult thing, either on exponents or on the nature of roots. If it throws you and it's not something you've seen before and you don't feel confident, don't waste your time. Make sure that what you have done is perfect. Work through everything slowly and carefully, and then you can come back later on. Okay. All right. So that is question number 1. You guys can look at the memo when you get it. All right. So let's have a look now at question number 2. And again, I'm going to rely on you to tell me what it is that you would like me to do with you from question 2. 2.2. Okay, let's highlight that. No problem. What else from 2.2? 2.3.2. Kutwano, you are out there in the front. Kalipa and Msomi said 2.4. 2.3.1 has also come up. 2.4 we've got. Okay, so a lot of us are saying question 2.4. All right. Okay, cool. All right. So let's just go through the other ones very quickly, and then we'll get to question 2.4, and I'll show you what we are supposed to do in this case. All right. So there is, in question 2.2, you have been given a quadratic rule, a quadratic expression, x squared minus x plus 1. There is no sum formula for a quadratic pattern. So that means that the only way that you would be able to do question 2.2 is by substitution and adding. Okay, so this means the sum x equals 1. Remember, the number at the bottom is the first number that we sub in. The number at the top is the last number we sub in. And the number of terms in the pattern is going to be the number at the top minus the number at the bottom plus 1. Okay, so number of terms when it comes to sigma notation is always the number at the top minus the number at the bottom plus 1. So there will be 4 terms. So essentially what this question wants you to do is this. You are going to calculate. First, we're going to sub 1 in. So I've got 1 squared minus 1 plus 1. That's the first term of the pattern. Now I'm subbing in 2, the next number. So that's going to be 2 squared minus 2 plus 1. Then I'm going to put in 3. So that will be 3 squared minus 3 plus 1. And then the last term is going to be plus 4 is going to go in. So 4 squared minus 4 plus 1. Can you see there are 4 terms in the pattern? And then all you need to do is pop that into your calculator and work out the answer. Okay, so the value of the first bracket is 1. The value of the second bracket is 3. The value of the next bracket is going to be 7 and then 13, and then that will give you an answer of 24. That's it. Okay. Letu, you know what I would do is it's not the first and the second. What you want to do is show the substitution. So the most important things to show is this line over here that I'm highlighting in yellow. Don't worry about this line over here, and then the answer is fine. Okay, so always show that you have subbed in. Yeah, always show substitution. Yeah, look, I think you probably would get all the marks. Yeah, all you need to do is add everything, because that's what the sigma notation means. It means the sum of something, doesn't it? Okay, so whenever you see the sigma sign, it is telling you to find a sum. There's no formula for a quadratic sum. There are only formulae for arithmetic and geometric sums. So the only way that you can do this is by subbing in and adding it all up. There is no formula that can be used to get to the answer quickly. Okay. All right, so now that we've done that, let's go and have a look. As always, I put things on top of one another. I'm so silly. All right, let's go and have a look at question 2.3 and then 2.4. Okay, so in question 2.3, we are given a finite arithmetic sequence. So when they say that a sequence is finite, it means that it ends. Okay, whereas infinite means it doesn't end, it carries on forever and ever and ever. So this minus 87 is the last term in the pattern. So when they ask us to calculate the number of terms in the sequence, we are going to use our TN formula because we don't have any sums here. Okay, all of these are terms. So we're going to use our TN formula. I'm just going to write it over here. So remember, TN equals A plus N minus 1D. Okay, so your nth term is this minus 87. So minus 87 will be equal to A is 5 plus N minus 1. And the difference between our terms, they're becoming smaller. So my difference is going to be negative. 1 minus 5 is going to leave me with negative 4. All right, now, what is very important here? Again, as Nelispa was saying in the chat, you have to show the substitution. You do not need to write the formula on the page. I put it here just so that you guys were sure about which formula that I am using. Okay, but you must show that you have subbed into it. The other reason why this is such a super cool question is because the difference is negative. There are so many times in matric exams, in tests and whatever, where matrics do not put the letter D in brackets. Remember, substitute, use brackets always. And then what happens is that that negative 4 is treated as a term rather than as a factor, and it doesn't get multiplied in. So make sure you put brackets around it so that you are multiplying. So now we'd get negative 87 equals 5 minus 4n plus 4, like so. All right, and then we can put the 4n on this side over here. On the other side, we can have all our terms collected together. That would give us 96. And when we divide both sides by 4, we would discover that there are 24 terms in the pattern. Okay. So that's question 2.3.1. Okay, it might be out of a little bit too much here. I would say that would probably only be out of 2, but it doesn't matter. A mark for subbing in and then a mark for your answer. There wouldn't actually be another mark here. I mean, maybe they could have a mark on using the correct formula, but that's normally they do that in financial maths. Okay, all right, let's move on and talk about question 2.3.2 now. Calculate the sum of all the negative numbers in the sequence. Okay, so now you know from question 2.3.1 that there are 24 terms in this particular sequence. The first 2 terms are positive. The rest of the terms are all going to be negative. So how many negative terms are there in the sequence? Exactly. So there are 22 negative terms. So you are finding the sum to 22. Okay, and your first term, your first negative term is going to be -3. So now I'm subbing into my sum formula for an arithmetic series. So that's n over 2 into 2a plus n minus 1. And my difference is still going to be -4. Okay, and then you can pop that into your calculator. Good, well done, Kalipo. Quite right. Pop that into your calculator and calculate it to be negative 990. If you wanted to, oh, what on earth is that? Sorry, guys. Sometimes it gives you these weird shapes when that's not what you were going for. Okay, you can also use that formula. It's not on your formula sheet, but it's the formula where you are working with the last term. So Sn equals n over 2, excuse me, oh, excuse me, into a plus L. You can also use that particular formula in this case because you know what the last term in the pattern is. You know that it's -87. Thank you. So your alternative here is to use, is to use Sn equals n over 2 into a plus L. You could also do that. That'll be on the memo as well as an alternative. Okay, and an accuracy on getting the 22, subbing in, and then our answer like so. Okay, now the moment we've all been waiting for, question 2.4. So let's get into that quickly. It says, given an arithmetic sequence has a first term equal to 7. Now, the mistake that we all make is that we write down T1 equals 7, and then that doesn't help us. All right, when you have been given a problem-solving question in sequences and series, they want you to think in terms of A and D for arithmetic series, and they want you to think in terms of, or sequences, or they want you to think in terms of A and R for geometric sequences and series. So don't write term 1 equals 7, write A equals 7. Okay, remember term 1 is A. Term 15 is A plus 14 differences. So that is your first equation. Your second equation, term 15, don't write T15 equals 35. It is A plus 14D, which is equal to 35. And that is your second equation. Good, well done, Gugu. And now we're solving simultaneously. All right, the only difference is that we don't need to isolate A or have an expression for A in terms of D. We know that A is equal to 7. So we can put the 7 in, substitute it in, plus 14D is equal to 35. Collect like terms on the right-hand side by saying 35 minus 7. That's going to leave us with 28. And when we divide both sides by 14, D is going to be equal to 2. Okay, so the value of the 8th term, term 8, is A plus 7 differences. Now that you know what D is, you had A to start off with, you can do that. Okay, so term 8 will be equal to 21. Was it easier than you thought now that we've been through it together? Yeah. Okay, so always when they give you problem-solving questions with arithmetic and geometric sequences, you write your terms in terms of A and D for arithmetic and A and R for geometric, and that will help you get to the answer. Okay. All right. I used A plus 14D equals 35 to solve for D. So if you look over here, Kotwano, this is what I was subbing into. Okay, so I subbed in my A over here. Do you see that? So I subbed in that A was equal to 7. So I subbed 1 into 2 and solved for D. Did you just miss that? Okay. Right. Oh, it's Kalipa. Sorry, Kalipa. Sorry, Kalipa. Okay. All right. So definitely an accuracy for writing that correctly, subbing in, calculating that, and then getting what it was equal to. Mary Lynn, you are welcome to do that. That's fine. I also love that method where you do elimination. So elimination works nicely. I don't need to eliminate here because I know what the value of A is. But let's say you've got something like this where you have got A plus, I don't know, 15D. I'm just literally making up numbers, Marilyn, equals 40. And then over here, you've got A plus 7D equals 20. When you've got both equations in terms of both letters, then elimination is a lovely method to use. Okay, but we don't need to eliminate it. We can if we want to. We would end up with the same answer, but it's just easier to sub the 7 in. But yeah, not a problem with that at all. I love elimination when I'm working with two linear equations. Okay, so yes, not a problem at all. All right, let's grab question 3. And what I'm going to do is I'm just going to scooch over all the way over here, and we can do question 3 here on the side. Okay, so when it came to question 3, which questions do you want me to do? Okay, so far we've got 3.1, 3.2, and 3. Okay, all right. So between all of you, you're saying all of them. Okay, so let me just start at the top, and I'll work my way through. Okay. So in 3.1, we can see here again we've got sigma notation. This is sum to infinity because we've got our infinity symbol up at the top. Okay, so they want us to calculate a sum to infinity. So we are going to use our sum to infinity formula. It is A over 1 minus R. So in other words, if I want to substitute in here, I need A and I need R. Remember, when they give me sigma notation, I need to substitute in order to create the terms in the series. So the first term will be A. Once I have got the second term, I can say term 2 divided by term 1, and I can get R. Does that make sense to everybody? So when I sub 1 in, it means that my first term is going to be 2 over 3. Then I'm going to sub in 2. Remember, the number at the bottom is where I start subbing in. So the next number is going to be 2 over 3 to the power of 2, which is 9. I suppose I could sub in again. That would be 2 over 3 to the power of 3, which would be 27. But it's pointless me going any further than that. So I can see here I've got a value for A. It's 2 over 3. I should have actually put that over here rather in terms of my setting out. So I've got 2 over 3 plus 2 over 9 plus 2 over 27. Those are the first 3 terms of this infinite series. Exactly. Now, so therefore A is equal to 2 over 3. Now I want to calculate R. Remember, R is term 2 divided by term 1. So I've got 2 over 9, and I'm dividing that by 2 over 3. So R is going to be equal to a third. Okay, good, perfect. So now I know what A is, now I know what R is, now I can substitute straight into sum to infinity. So sum to infinity is A, which is 2 over 3 over 1 minus R. Okay, and when you sub in, you should see you get an answer of 1. Okay, so that was out of 3. Subbing in answer and maybe an accuracy on A and R as well. Okay. Let's go on to 3.2 now. When it comes to converging geometric series, there is a restriction on R. You're not getting 1. So now, Kutwano, what could possibly be going wrong here is what you're doing on your calculator. What you're telling your calculator to do and what it's actually, okay. All right, now just be careful about how you are putting it into your calculator. You should be getting 1 as an answer. You're getting 1 over 3 as well. Okay, all right, let me just double check myself. Hold on a second. 2 over 3, whoopsie. Nope, it's definitely 1, guys. Yeah. No, you should be getting 1. It's not wrong. So what this tells me now is that the way in which you are using your calculator is incorrect. Okay, what you are telling your calculator to do and what the question actually means are not the same thing, right? And this often happens when we've got a fraction over a fraction. So save yourself the trouble. Do this, put this into the calculator. Use your fraction button and press 2 over 3 and then use the old-fashioned divide sign and then go 1 minus a third in brackets. Okay, fractions over fractions often give wrong answers. Okay, and yeah, as Nelisa was saying, the other way to think about it is that 1 minus a third is 2/3. 2/3 divided by 2/3 is 1. Anything divided by itself is 1. Aha. Okay. All right. Let's go and do question 3.2. Right. So what is the restriction on R for a series to converge? Almost Letu. That's it, Kutwano. Okay, that's it. Beautifully put, Mary Lynn and Gugu. Beautiful. R has to be between -1 and 1. Okay, so what you are going to do now is you are going to work out what R is in terms of X. So remember, R is term 2 divided by term 1 or term 3 divided by term 2. So here we've got 4x cubed divided by 8x squared. So that is going to give us half x. Exactly. And now we are going to sub that half x into R is greater than -1 but smaller than 1. And to get rid of the half in the middle, remember we don't want to solve for half x, we want 1x. So we are going to multiply every term by 2. So that gives us x in the middle. So x has to be greater than -2 but smaller than 2. And those are the values of x for which the series will converge. All right. So we had to get the half x, sub it in, and then our answer like so. In 3.2.2, we want to calculate the value of x if the sum to infinity is 8 over 3. Whoopsie, sorry, my pen's doing these weird, horrible things again. Okay, so remember your sum to infinity formula. Sum to infinity is a over 1 minus r. So this 8 over 3 is our sum to infinity. So we've got 8 over 3 is equal to, what is a in terms of x? What is a in terms of x? What's the first term of the series? It is 8x squared, isn't it? A is 8x squared. Lovely. So we're going to put 8x squared at the top. We already know what r is equal to. So in our denominator, we've got 1 minus r. So we've got 1 minus half x in the denominator. Is everybody happy with how I have subbed in? Okay. Right. And then you'll see, sorry, just so that you are aware, there was just a little typo on the memo. Okay, so on the memo, this inequality sign is just pointing in the wrong direction. So just be aware of that when you are, okay, your inequality signs have to point in the same direction. So this one that I'm highlighting in yellow is just pointing in the wrong direction. Okay, it's got to be like this. Okay. All right. And now, how are we going to solve for x, guys? What should we do here? What method should I use? That's it, Mary Lynn. Beautiful. Everybody else, what are we doing? That's it, indeed. We are going to cross multiply. Okay, good stuff. So we've got 8 into 1 minus half x is equal to 3 into 8x squared. So this will give us 8 minus 4x equals 24x squared. So it's quadratic. I'm going to bring everything over to the right-hand side. And at this point, you can either use the quadratic formula if you want to, or I can divide through by 4 and then factorize. Okay, so I personally prefer factorizing, but if you want to use the quadratic formula, it's not a problem at all. Okay, what would you prefer I do here? Is there any preference? Either. Okay, all right. So if I divide through by 4, I would end up with 6x squared plus x minus 2. And I'm going to have 2x and 3x. I'm going to put my 2 here, my 1 there, and I now have 6x squared. So I want positive 4 minus 3, and my solutions for x. X is going to be equal to 1 over 2, or x is going to be equal to negative 2 over 3. Okay, so in both of these cases, oh no, there would not be a restriction. Sorry, I was just thinking. Yeah, and then factorize. Okay, so Either use the quadratic formula or you can factorize. The choice is yours. If you use the quadratic formula, make sure that you have subbed in. In all your quadratics, do not be lazy. Do not just write the 0 here first and then don't write it here and then you don't write it there. It must be on all those lines. Okay, often this line over here is the one that carries an accuracy mark. It's an accuracy mark for your factors. If you have not got the equal 0, they will take that mark away from you. Okay, so make sure that the zeros are there. Okay, not in this case. No, sorry. I just went back to go and check if there was, but there is no restriction on X. There would be a restriction on R, but there wouldn't be a restriction on X in this case. Okay, we wouldn't, and that's something else, Somi, that a lot of people do. Like they get a negative answer and then they're like, oh, it can't be negative. Well, why? It depends on what you are calculating. So in other words, if you are calculating n in sequences and series, then yes, n can't be negative. Or if the question comes with a restriction and it says that there are only positive terms or whatever, then something can't be negative. So go back. If you get two answers for something, go back and read the question again. Just to make sure that you are, if there is a restriction, that you are adhering to that. And if there's not one, don't cross out one of your answers. Okay. All right. So that was out of 4 marks. So mark on the factors, mark on the answers, definitely a mark on our first line for subbing in. And let's say there would be a mark on either of those two, getting it into standard form. Okie dokes. Let's do question 3.3 now. It's amazing how the time goes. Would you guys believe we've already been busy for an hour? We've only got half an hour left. Okay, let's jump into it. So, determine the sum of the geometric series to 15 terms. Okay, so this is a geometric sum. So we're going to use sum to 15 is equal to, so remember your geometric sum formula. I'm just going to write it in black over here. Your geometric sum formula is Sn equals A into R to the n minus 1. Be careful that minus 1 is not part of the exponent over R minus 1. That's what I'm subbing into. Okay, so this is going to be 45 over 4 into the value of R. I can work out on my calculator. So I can say 135 over 16. And then I can divide that by 45 over 4, and I get an R value of 3 over 4. So this is going to be 3 over 4 for R to the power of 15 minus 1 all over R minus 1. Okay, so now what I'm going to do is I'm going to bring up my calculator just to show you how to get this into the calculator properly in this case, because you don't want to, just hang on one second, let me just get the calculator. Where is it? There. And then I think I need to reshare my screen because you can't, I don't think you guys can see the calculator right now, can you? Calculator, you're going to go over there. No, okay, all right. New share screen. Okay. Is it cool? Can you see my calculator now? Yes, okay, all right. So we're going to press the fraction button. And then we're going to make sure that we are in the numerator. Can you see my cursor is flashing in the numerator? And then we're going to press the fraction button again. So now we've got 45 over 4. And now I'm going to put in my brackets. Okay. And then I'm going to put in another bracket, fraction button again, 3 over 4. And now I'm going to close my brackets. Exponent to the power of 15, come to the side, minus 1, and then I'm going to close my last bracket. Okay, Gugu's got an answer already. Good, Gugu. Now we're going to go down into the denominator. Okay, and I'm going to press the fraction button again. And I'm going to put 3 at the top, 4 at the bottom, and then I'm going to take away 1, and now I can press equals. Am I getting the same answer as you, Gugu? There we go. Good, well done. And you all of you are rounding nicely to 2 decimal places. Beautiful, well done. Okay, so we would get 44,40. You got that too. Lovely, well done. Okay. All right. So they told us the number of terms here. So it's literally just a mark for subbing in and then a mark for our answer. Okay. All right. So is everybody happy with that? Are we all feeling good? I can jump on to the next question. Yeah. Okay, cool. All right. So now question 4. Let's just move this down and over a little bit. There we go. And now we've got everything on screen. Okay, hopefully that's big enough and you can see it. Luckily, you've got this written down on the page in front of you. Okay, so there's some nice difficult questions towards the end here, which, yes, Mary Lynn. Okay, because then you haven't rounded correctly. Okay, so it would be wrong. Okay, so remember on our calculator, it's 44.398. Okay, so because of this 8 in the third decimal place, it pushes that 39 into 40. Okay. Yes, Kutwano, I can understand why questions 4.6 and 4.7 would be the difficult questions in this particular case. That makes sense to me. Let's just see what else other people were saying. 4.4, saw me. 4.3 says Josh. Okay. All right. So when it comes to these questions over here, what we did in question 4.1, the information that we calculate further up is information that we're going to calculate further down. All right. So what I just quickly want to do is just go through 4.5 says Mbali. Okay, so that's pretty much the last. Okay, so tell you what, let's just quickly whip through the first couple of questions because we're going to need those answers to be able to do the rest of it. So let me just quickly start up at the top. It's not going to take us long. This is only out of 3 marks. So the first thing that they want us to do is calculate the value of P. Remember, begin by reading the question carefully. So they've told us f of x equals log px, g of x equals ax squared plus bx. And they're sketched below. A is the turning point of F, and B is the common x-intercept of F and G. The point C, 2 and minus 1, also lies on the graph of F. So now, when they want us to calculate the value of P, we would just do that by subbing in. Okay, so we're going to sub into the formula for f of x. So, and we can use this point C that lies on the line. So it's -1 is f of x equals log P, and then our x in this case is going to be equal to 2. Okay, so log base number equals your exponent. So your exponent is -1. All right, so in other words, now if we've gone from log form, we're going back to exponential form. So that means our base is P. our exponent is -1, and our number is 2. Does that make sense to everybody? And then we've got 1 over p equals 2. We're going to cross multiply, and p, sorry, I'm just looking at what you guys are saying, is going to be equal to 1/2. Is everybody good with that? Oh, good. Okay, so p is 1/2 in this case. Okay, cool beans. Write down the coordinates of b. So for you guys, for log functions, they don't, in the CAP syllabus, we don't shift our functions left and right and up and down. They could ask you a difficult, maybe translation sort of question, but you will know that the coordinates are going to be 1 and 0. Okay, that's something that can be learned. Okay, let's jump into question 4.3. So now they say to us, if p equals 1/2, so, if you wrote that down on the page, they wouldn't give you any of the marks for it because you could have read it in 4.3. So they would need to see the working, okay, in 4.1. 4.3 now, if p is equal to 1/2, determine the coordinates of A. All right, so when it comes to the coordinates of A, we have to think very carefully about, now this is quite a difficult question. We have to think about, because we know that A is the axis of symmetry. That is what's key to us being able to answer this question. So we know that the graph goes through the origin. We can see that from the formula for g of x, and it's on the diagram. We've just worked out what the coordinates at B are. So in other words, we've got the two. Oh, can I repeat 4.2? So 4.2 is learning, Josh, because this graph is the inverse of the exponential function that looks like this. So if this is the graph y equals 1/2 to the x, its y-intercept is going to be at 0 and 1. Remember, if you take anything and you raise it to the power of 0, you're going to get 1 as an answer. So now when we sketch the graph that's on the screen, the one in orange, what was your y-intercept is now your x-intercept. So it's at 1 and 0. Okay, and that's what's on the screen at the moment. This is f of x. Pleasure. Okay. All right, so in 4.3, we know the x-intercepts of our parabola. We know that a parabola is symmetrical about its axis of symmetry. So if you want to work out the x-coordinate at A, you can use midpoint formula. So you've got 0 plus 1 over 2. That gives you 1 over 2. Does that make sense to everybody? So therefore, at A, oh, sorry, I meant to write a colon and not an equals. At A, let's just go back to blue, x will be equal to 1 over 2. Is everybody happy with that? And then you can work out what y is. So f of x or y is equal to log base number. Pop that into your calculator and you'll get an answer of 1. When they ask for coordinates matrix, give them coordinates. Okay, so write down here that the coordinates will be 1 over 2 and 1. Okay, are we all right with that? Is that making sense to everybody? Yes. Are we all good? Thank you, Anam. Okay, Msomi. Okie dokie. Question. No, ma'am. Okay, Simpiwe. Mary Lynn, you're all right. Simpiwe, you saying no. What's wrong, Simpiwe? Okay, so, all right. Neliso, do you want to assist Simpiwe with this question? Or is there a lot of other people that are also feeling stuck with 4.3? Okay, so Neliswa, can you assist Simpiwe, please?
Yes, I need. I know it in my head.
All right, that's fine. Okay, so you would use the calculator to get the 1. All right, so again, let me bring up my calculator. Where's it gone? Why is it not here now? Okay. Can you see the calculator on screen? Cool. Okay, so Mbalenhle, you're going to use this button over here. Right, you can write 0.5 or you can press the fraction button and put in 1/2. And then over here, we're going to scooch over to that. Again, we're going to put in the 1/2, and now we're going to press equals. That's why we get 1. Okay. All right, no problem. Okay, question 4.4. Now they want us to calculate the values of A and B. Right, so these are the coefficients of our x squared term and our x term in our formula. Right, there are about 3 different ways in which we could answer this particular question. You could use simultaneous equations. You could use the x-intercepts. How else could you do it? I'm just trying to think. You could use turning point form because you know what the coordinates at the turning point are going to be. You know what A is. So there's 3 different ways in which you could answer this particular question. I think what I am going to do with you guys is I am going to use this formula. So y equals a, x minus, and then either your teachers will go x1 and x2 or root 1 and root 2. Does that ring a bell? Does that look familiar? But you've got the coordinates at the turning point, so you can also use turning point form. Okay, this one is an important one to remember, and that's why I've decided to go through this with you, just to sort of refresh your memories and refresh your memories. Okay, so you'll see on the memo, yeah, absolutely, Letu. Why are you using this form? Because they want you to find the equation, Josh, of the parabola. Okay, so if you don't use this form, the other forms that you have available to you is turning point form. So that is x plus p squared plus q, which you could use if you wanted to. Or you could work with it like this, y equals ax squared plus bx, and then you could solve simultaneously. But if they ask you to solve for A and B, they're essentially asking you for the equation. So the reason I've chosen to do it this way is because you know what the x-intercepts are of your parabola. Okay, so what I'm going to do is I'm going to sub in my x-intercepts first. Remember, my one x-intercept is at 0. The other one is at 1. So y equals a, sorry, beg your pardon, x minus 0, x minus 1. There my x-intercepts have gone in. Okay, I know what the coordinates at A are from question 4.3. I know that that was a half and 1, wasn't it? Okay, so now I'm going to sub in my point, and that's going to allow me to solve for A. So 1 goes here, and our half is going in place of the x's. Pleasure. All right, now these two brackets are being multiplied together, and then they will be the coefficient of A. So a half minus 0 is a half, and a half minus 1 is a negative half. So a half times a negative half is minus 1 over 4. That will be the coefficient of A. All right, and we were expecting a negative answer for A because the graph is concave down. It is a sad face parabola. And again, matrix, you are going to cross multiply, and A will be equal to negative 4. All right. Everybody okay with that? Okay, and now we need to work out the value of B. All right, so what have we got so far? We've got y equals 4x squared plus bx. I'm going to sub in my turning point, and I'm going to solve. So I'm going to put 1 over here. X is equal to 1 over 2 plus b times 1 over 2. Okay. And that would leave me with 1 equals a half squared would be 1 over 4. So this would be 1 plus a half b. And yes, absolutely. Absolutely. Not a problem. Not a problem at all. I'm just, there we go. So minus 1 over 2b is equal to, have I done something funny here? Just look at my own notes.
Isn't it because the available point is a turning point?
Say again, Neliswa.
That the point you use, the 1 is to 1, I mean the 1 over 2 is to 1, isn't it a turning point?
Yes, but I mean, theoretically, you should be able to sub any point in.
Oh, okay.
I'm not going to sub, I wasn't going to sub in the x-intercepts because, okay, tell you what, I don't know why this, am I just being silly here? So what we should be able to do here is we should be able to sub in any point that lies on the line in order to be able to work out the value of B. So that's 1 and 0. Let me just, so 0 equals 4 times 1 squared plus B times 1. I don't know, maybe I was just being silly. Okay, so 0 would be equal to 4 plus B. So B would be equal to -4. All right, maybe that's the easiest way to do it. I'll just sub in
Oh
the
yeah,
x-intercept.
A is negative, like -4.
Yeah, A is -4 and B is also -4. No, B is supposed to be equal to +4, isn't it?
Yeah, it's like when you substituted A, you just said 4 instead of -4, I think.
Oh, that's why it didn't work. Okay. I knew I'd made a mistake somewhere. Sorry, guys. I knew there was nothing wrong with the point that I used. Okay. Sorry, my mistake. Okay, so that's what it was. So y equals -4x squared plus bx, and then it doesn't matter. I would stay away from using the coordinates at the origin because then obviously that's going to make your b term equal to 0. So you should be able to sub in point A, or you should be able to sub in point B or any other point, so long as your x coordinate is not 0. Okay, so subbing in point B now, if we sub in B, we could also sub in A. Sorry, I knew there was something I'd done wrong, but I couldn't see. Sorry, it's because I didn't have the negative in front there. Okay, so now 0 is equal to -4 times 1 squared plus B times 1. Okay, so therefore B would be equal to +4. Okay, cool beans. So we have, was it h of x, g of x? G of x is equal to -4x squared plus 4x, like so. Okay. Let's see if we can finish this off by the time we need to say goodbye. We don't have an awful lot of time, but I can always come back to these concepts again next week. Okay, so 4.5 now. They want the equation of the inverse of f. Okay, so f of x is log half x. So your inverse, we are going to switch x and y around. So we've got x equals log half y. And now I want to write it as y equals base to my exponent of x. All right, so the inverse is a log graph, and it is log half x, like so. Sorry, man, is an exponential function, and it is half to the x, like so. Okay, is everybody all right with that? Yes, good stuff. Okay, let's get into the last couple of questions, which I know were the ones that were the problem for us. So they want us to determine the values of x for which f of x is greater than or equal to -1. Now, they do not expect you to solve a logarithmic inequality in the CAPS syllabus. All right, so that means that we have to be able to look at the graph and see what the answer is. So remember, our graph, f of x, is log half x. And we want to know for which values of x is the graph greater than or equal to -1. So what you can do here is look at the part where it is equal and use that as your starting point. right? So for what value of x is log half x equal to 1? For which value of x is log half x equal to -1? Well, we can solve for that value of x. We know how to do that, don't we? Okay, so x, our base, to the power of -1 will be equal to that x value. So that means the value of x where it's equal to -1 will be when x is equal to 2. Is everybody happy with that? So in other words, if we have a look, it's actually this point over here. Do you see that? Y is equal to -1 and x is equal to 2. So for which values of x will the graph be greater than or equal to -1? -1 is this line over here. There's the line where y is equal to -1. So where is it going to be greater than this? It's going to be over here. Okay, so from 2 back towards your x-axis, right? But you cannot include, sorry, your y-axis, but you cannot include the y-axis because it is an asymptote. All right, so this is going to be where y is smaller than or equal to 2. Sorry, oh, man. Where x is smaller than or equal to 2. And then we would have to say over here that x cannot be equal to 0. The only other way that you could set this out is you could say x is an element, and then here you round bracket with the 0, and then the 2 would have a hard bracket. That would be the other way you could set your answer out. Okay, is everybody all right with that? And then I just quickly want to do the last question, which is 4.7. Gugu, you're okay? So it would come from the graph. You would use this point over here to assist you with your answer for that particular question. Okay, but I'm just showing you why it would be that point that we would use. The only thing they would obviously mark here would be your answer. All of this other working that I did up there would not carry any marks at all. Okay, let's finish this off. Question 4.7. So now they say to us, determine the values of x for which f of x times g of x is smaller than or equal to 0. So if they tell us that two different values are being multiplied together and the answer that we are getting is negative or equal to 0, either this must be negative to give us a negative answer, or the other one must be negative to give us a negative answer. So what we are looking for is where the two graphs are in different places in terms of your x-axis on the graph at the same time. All right, so if we go and we have a look, right, remember the y-axis is our asymptote. So if we look to the right of the y-axis, over here, your parabola, g of x, is positive, where the pink is. Is it A and C? Do you mean at points A and C? hang on a second. Okay. All right. So the reason why, sorry, I'm struggling to answer this question, and you would have done as well, is because the answer for this is x is an element of the real numbers. Okay, so the question, sorry guys, I've just had another look. The question was supposed to be g prime x. Okay, so sorry, there was a little typo with that question. So it was f of x times g prime x has to be smaller than or equal to 0. Maybe that's why there was an issue with us being able to do this particular question. All right, now it makes more sense to me. Okay, let's go and have a look. So f of x, so again, it doesn't matter. We can adapt it like this, right? G prime x means gradient, right? So either the gradient is positive or the gradient is negative. So if we consider where G prime x is positive, G prime x will be positive before the turning point. The gradient is positive. Then the gradient will be negative after the turning point. So this is where G prime x is negative. When it comes to our graph of f of x will be positive above the x-axis, and it will be negative below the x-axis. All right, so what we want are two opposites. All right, if the graph is increasing like it is in pink, and the graph of f is above the x-axis, then the pink and the yellow are positive times positive. So that's not going to give us what we want, because we want our solution to be smaller than or equal to 0. If we see at A, what we notice is that at A, the graph becomes decreasing function, the parabola, the blue, but the graph of f is still above the x-axis. So it's not between A and C, Marilyn, it's between A and B. The parabola is decreasing while the graph of f is above the x-axis. Okay, so your answer here is going to be where x is greater than or equal to 1/2, but smaller than or equal to 1. From B onwards, the graph of f is negative and the graph of g is a decreasing function. So it would not meet our criteria. Okay, and that's how we would do that question. Oopsie, I'm sorry, I've gone a little bit over. Is everybody all right with that?